Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is for topic 2, polynomials and rational function. Okay, so let's first we go into 2.1 for polynomials. So our learning objective at the end of the lecture, students should be able to perform addition, subtraction and multiplication of polynomials. Second, to perform divisions of polynomials. Okay, what is a polynomial? Okay, you can see that here a polynomial is an expression in the form of ax to the power of n, and then the degree of the power will be reduced by 1. So you can see here in the table, so the degree can be from 0, and that is called as a constant, same as a constant function that has no degree of x, so it becomes a constant function. So when the degree is 1, the graph is called as or the polynomial is called as a linear, when the degree x to the power of 1. And then we have a second degree called as quadratic, third degree as cubic, and fourth degree as aquatic. So these are the examples for different degrees in polynomials. Next, a polynomials can also be added, subtracted, multiplied and divided. Okay, so firstly we look at polynomials that can be added and subtracted. Polynomials okay, so these are the examples for addition of polynomials. So it's a easy one, a common one that you always do. 2x power of 3 plus 5x square minus 3x plus 1 plus x power of 3 minus 2x square plus 4. So in order to do operation of addition for polynomials, only the same degree of polynomials can be added or subtracted. Okay, for example, we look at this 2x power of 3 can only be added with the same degree x power of 3. So then we have 2x power of 3 plus x power of 3, and then followed by 5x square minus the same degree 2x square, and then we have 3 negative 3x, and then no pair, and then we have plus 1 plus 4. Okay, the same degree added with the same degree, and the same degree minus with the same degree. And then we have here is 3x power 3 plus 3x square minus 3x plus 5. So this is the answer for addition for two different polynomials. So this is polynomials number 1, and this is the second polynomial. Okay, this is the example for addition and subtraction. Okay, next we go for example for multiplication for polynomials. Okay, multiplication of polynomials. Okay, so multiplication of polynomials is represented in brackets. For example, we have x power of 3 plus 2x square minus x, and then we have x square minus 3x plus 2. Okay, so when you see these two brackets, they are placed next to each other, so it indicates a multiplication operation. Okay, so each of the term in the bracket need to be multiplied with each of the terms in the second bracket. So that's mean we have x power of 3 multiply with x square. Okay, and then we have x power of 3 multiply negative 3x plus x power of 3 multiply with 2. Okay, that is for multiplication between x power of 3 and x square. and negative 3x and 2. So next we go for multiplication for second term, that is the 2x square. So this 2x square we multiply with each of the terms in the second bracket. So that means we have plus 2x square and x square plus 2x square and negative 3x and plus another one, that is 2x square multiplied with 2. Okay, so don't forget our third term, that is the negative x, that also need to be multiplied with all of the term in the second bracket. Okay, so we write it here, and plus another negative x, and we have x square plus negative x, negative 3x plus negative x and 2. Okay, so now next we solve for each of the multiplication for the brackets. That means we have 3x x power of 5, sorry, not 3, x power of 5, and then negative 3x power of 4 plus 2x power of 3 plus 2x power of 4 plus, sorry, minus 6x power of 3 plus 2x square, and then negative x power of 3 plus 3x square and negative 2x. Okay, so after the multiplication, we do the operation of addition and subtraction for the same degree of x. So there's only one x power of f, x power of 5. Okay, then we go for negative x power of 4 minus 5x cubed plus 7x square and minus 2x. Okay, so that is the multiplication for polynomials. Okay, now let's move about division of polynomials. Okay, we represent polynomials with the symbol of px. Okay, so let's say when we have a polynomials, px is divided with another polynomials, and we call it as a dx. Okay, which is called as the divisor. So the d comes from the d from divisor, and then the answer from the division will give a quotient. A quotient that is represented with the symbol of qx, and a remainder, if available, that is represented by rx. Okay, give a quotient of qx and a remainder that is represented by the symbol of rx. Okay, the formula is, let's say we have px, polynomial divided by a divisor dx, and it will give you the answer that is called as the quotient qx plus the remainder rx over the dx. Okay, so if you are confused what is meant by all of this, never mind, I will show you an example after this. Okay, forgot about one thing. This formula can be simplified, so it becomes px equal to qx dx plus rx. Okay, so this is the example that I wanted to show you. Let's say we have a polynomial px equal to 2x power of 3 minus x square plus 3x plus 1, and the divisor is equal to x minus 2. Okay, so now we want to divide the polynomial with the x minus 2. So that means we have px over dx. Okay, the way to do this is to rewrite the operation in this form: x minus 2, and then we have 2x cubed minus x squared plus 3x plus 1. Okay, so now let's do. Okay, so we have 2x cubed. So in order to get 2x cubed, that multiply with x, so the up here we should write 2x squared, and then it will multiply with x, and it become 2x power of 3, and we also multiply with negative 2, so we have negative 4x squared. Okay, so we do the operation of minus. This will give us 0, so negative x squared minus 4x squared, so it becomes a process of addition. So the answer will become 3x squared. So we bring down the 3x plus 3x. Okay, so we go to the next step is to remove the 3x squared. So in order to get 3x squared, we put up here a plus 3x. So 3x multiply with x from the divisor, and then we get 3x squared, and then 3x multiply negative 2, we have negative 6x. So once again we do the operation of minus, subtraction. So we get here 0. You must do operation of minus in order to get 0. 3x squared minus 3x squared, so it will give us 0. So negative plus positive 3x minus 6x, so the answer will be 9x. So we bring down plus 1. Okay, so next we multiply with 9, so it become 9x minus 18. So operation of minus, 0, and we get here 19. So there is nothing left that we can bring down, so that is our solution. So as we can see here, this is our divisor represented by dx. This is our polynomial px. Okay, and then this is our quotient qx, and lastly we have 19 as our remainder represented by rx. Okay, so these operations, this method can be rewrite in the form of the formula given to you just now. So that's mean px over the divisor dx equal to quotient qx plus the remainder rx over dx. So that is equal to, 2x power of 3 minus x squared plus 3x plus 1 divide with the divisor x minus 2, and it give you the answer of 2x squared plus 3x plus 9 plus the remainder over the divisor. Okay, so this is our answer from the division between two polynomials. Okay, the condition is that, okay, the degree of the divisor must be less than the degree of the polynomials. What I mean is right here, we can see that the divisor is x to the power of 1. Meanwhile, the degree of the polynomial is x to the power of 3. Okay, when the degree of the divisor is less than the degree of the polynomials, only by that the polynomials can be divided by the divisor. Okay, let's look at more examples for operations, addition, subtraction, multiplication, and division for polynomials. Okay, so our example is, okay, let's say we have three polynomials. Px equal to 2x cubed plus 5x squared minus 3x minus 4. Okay, then qx, okay, this qx is not a quotient, okay, it's not quotient, but it's a polynomials, okay, another polynomials. X power of 3 minus 6 x squared minus 2x plus 7, and then we have rx, also not a remainder but just to represent our third polynomial. So 3x plus 1. Okay, so our first example, let's say example 1, an easy one, to perform addition for polynomials. Px plus qx. Okay, so px plus qx will become, so px is 2x power 3 5x squared minus 3x minus 4, and plus with the qx, okay, then plus 7. Okay, so from these two polynomials, when added, so the same degree can only be added with the same degree, and also the same thing goes for operation of subtraction. So then we have 3x power 3 minus x squared minus 5x plus 3. Okay, so that is an easy one, because you did this for many years already, right? Okay, and then let's jump to examples that includes the operation of multiplication. Let's say we have px dot rx. So this means we need to multiply polynomials of px with polynomial of rx. So equal to 2x power 3 minus 3x minus 4 multiply with rx. Okay, so from this one, so each of the term need to be multiplied with each of the term on the other bracket. So that give us 6x power 4 plus 2x power 3 plus 15x power 3 plus 5x squared minus 9x squared minus 3x minus 12x minus 4. Okay, then we simplify, we do addition and subtraction where the x come from the same degree. So 6x power 4 plus 17x power 3 minus 4x squared minus 15x and minus 4. Okay, that is the example for multiplication for polynomials. Okay, now let's look at another examples for division. Okay, our example number 3. Okay, now we want to find the qx divided with rx. Okay, now we want to find qx divided with rx. So that's mean we have to find x power of 3 minus 6x squared plus 7 over 3x plus 1. Okay, so in order to do division, we must write the operation in the form that you did during your elementary schools. 3x plus 1, 3x power of 3, x power of 3 minus 6x squared minus 2x plus 7. Okay, so firstly we have x to the power of 3. So in order to get x power of 3, so we choose, or we take 1 over 3 x squared. Okay, 1 over 3 x squared, when multiply with 3x, so we will have x power of 3 minus 1 over 3 x squared. So then we do the operation of minus, and then negative cx squared minus 1 over 3 x squared minus negative, so it becomes a positive. So our consequence is negative 17 over 3 x squared. So then we bring down to x minus 2x. Oh, sorry. Okay, then we need to solve for negative 17 over 3 x squared. Okay, so in order to eliminate that number, so we multiply negative 17 over 9x with 3x, with this 3x. So that will give us negative 17 over 3 x squared minus 17 over 9x. Okay, so a negative meets operation of minus, so it becomes a positive, so it will become 0. So negative 2x minus negative 17 over 9x, so that is negative 1 over 9x. So then we bring down positive 7. Okay, so in order to remove negative 1 over 9x, we take negative 1 over 27 multiply with 3. So then we have right here negative 1 over 9x minus 1 over 27. Okay, then another operation of negative, so we have 0, and then we have a remainder of 7, 1 over 27. So that is our remainder. So the final answer, we can write it qx over rx, it will be equal to 1 over 3 x squared minus 17 over 9x minus 1 over 27 and plus the remainder, that is 190 over with 27 3x plus 1. So that is our final answer for polynomial qx divide polynomial rx. Okay, let's look at more examples on long division. Okay, let's say we have 6x cubed minus 2x squared plus 7x plus 5 divided with x minus 1. Okay, so we rewrite it in the normal division form, x minus 1, 6 to the power of 3 minus 2x squared plus 7x plus 5. Okay, so this one you want to eliminate 6x power of 3. So we take 6x squared. So 6x squared times x, 6x cubed minus 6x squared. Okay, then we have 4x squared plus 7x. Okay, so then we choose 4x, become 4x squared minus 4x, then it becomes 0, so then we have 11x plus 5. So then we add 11x, sorry, we choose on the 11, so it become 11x minus 11. So we have a remainder of 16. Okay, so our final answer is equals to 6x squared plus 4x plus 11 plus 16 over x minus 1. Okay, so let's say if the question want us to label, want us to state what is the quotient of the quotient that comes from the division. So the quotient qx is equal to 6x squared plus 4x plus 11, and if the remainder is equal to 16. Okay. Okay, another example, 7x power of 4 minus 3x cubed plus 6x plus 1 divide with x plus 3. So we have x plus 3. So x plus 3 so 7x4 minus 3 x power 3 plus 6x plus 1. Okay, so first we start with 7x power 3, 7x power 4 plus 21x cubed. Then we have negative 24x power 3 plus 6x. Okay, so next we take negative 24x squared. So we have negative 24x power 3 minus 72x squared. Okay, so next then we have 72x squared plus 6x. Alright, we plus 6x because we have 6x minus negative 72x squared. This 6x is in the different degree from negative 72x squared. So since the operation here is a negative, so that's why the 72 becomes a positive number, x squared plus 6x. Okay, we do not take down the number of 1 yet. We solve for 72x squared plus 6x first. Okay, what we do is next we plus 72x, so it becomes 72x squared plus 216x. So we are left with negative 210x. Okay, now then we take down the number of 1. So minus 210. So we have negative 210x minus 630. So we are left with remainder of 631. So the answer is equal to 7x cubed minus 24x squared plus 72x minus 210 plus 631 over x plus 3. So that is our remainder.